Welcome back. We're going to continue our discussion of congruent figures and more specifically congruent triangles. Congruent figures are, geometric figures are congruent if they are the same size and shape. Okay, remember when we had transformations on the coordinate plane, we said that any transformation that was an isometry preserved congruence. So the figure might have changed position or changed orientation, but overall their size and shape are the same. So corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Now don't get this corresponding angles phrase confused with the corresponding angles we saw when we had parallel lines. Okay, this is a different meaning of corresponding angles, and we'll see in an example in a minute. Two polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. Now, please notice that this says if their corresponding sides are congruent, then the polygons are congruent. It doesn't say anything about their angles. Okay, so just having three angles congruent in two different triangles is not going to be enough to prove triangles congruent. We need to know that their sides are congruent. And there will be other ways that we will have to prove triangles congruent, but for now we're just going to be looking at their sides being congruent. Okay, properties of congruent polygons. Okay, and here's what where we'll solidify what we mean about corresponding angles and corresponding sides. See the diagram on the left of the two triangles. We're saying that triangle ABC is congruent to triangle DEF. Their vertices are named in order of correspondence. So angle A corresponds to angle D, angle B corresponds to angle E, and angle F corresponds to angle C. And notice the way we name the sides. Okay, we say that side AB corresponds to side DE. Okay, so in the triangle on the right, we don't name that segment from left to right. We name it from corresponding vertex to corresponding vertex. AB is congruent to DE. BC is congruent to EF. AC is congruent to DF. And yes, I will be picky about that. Similarly, we see this in the congruent polygons down below as well. Okay, so when we write a statement such as triangle ABC is congruent to triangle DEF, you are stating which parts are congruent, like we saw in that last diagram. Let's take a couple of examples using corresponding parts of congruent triangles. Okay, so we're given that triangle PQR is congruent to triangle STW, and we're asked to identify all pairs of corresponding congruent parts. Okay, well, it might help to actually draw the triangles. Right, so PQR is congruent to STW, and since we're at liberty to draw the triangles however we want, we might as well draw them so that it looks like their corresponding parts are in the same positions. Okay, so I'm actually going to write over in a different color just to highlight those corresponding parts. Okay, so we can say that angle P is congruent to angle S, that angle Q is congruent to angle T, and angle R is congruent to angle W. Okay, the angles are the easy ones. Okay, so now when we want to identify the sides, we want to make sure that we're listing the vertices in corresponding order. So side PQ is congruent to ST. right? And if I call it side QR, it's congruent to TW. Okay, I can't call that side WT. Okay, notice the colors here. I'm listing them in corresponding vertex order. And then finally, side RP is congruent to side WS. Okay, now what if I had listed that last one as side PR? Well, that side would be congruent to SW. Okay, so it doesn't matter which order you list them in for the first triangle, right? As long as you list the second set in corresponding order. Okay, so I could have called